practical exercise for you in this afternoon is to develop networked application which initially was input-output Java standalone application, and what is already given to you is following: that there is class TTT-CLI as a tic-tac-toe client implementation of this game as a basic Java standalone application which uses input and output as its interfaces. And if we run it, I will run it inside terminal because there is terminal in Eclipse as well and in IntelliJ IDE as well here, but it is not so feature rich, and therefore I don't like it to use it somewhere here. For example, here we can do everything we like, but I tend to use dedicated terminal application for my needs. So if I run this already implemented application, it allows to play simple implementation of a tic-tac-toe game in the following way. So when you start it, it prints out board, these numbered cells starting with 0 and ending with whatever this number of cell is, and then two users how to play on the same terminal, so they need to sit side to side on the same computer, and then one can enter number of cell, another user reviews position, enters another cell, and then they continue until game is ended. If somebody enters wrong cell number, application says wrong move, nothing else changes. And if some abracadabra is entered, it even doesn't care about proper formatting issues, so it doesn't have great error handling, so it works properly only if proper data are entered. Another thing what this cell can do with TTT-CLI, you can pass one argument for it, and then this is one side or dimensions of this board game. And if you say that board should be 10 by 10, then cells are shown just by single digit, only last digit is shown here. So example, cell number 99 is this one, and cell number 0 of course is this one. And so it reads from standard input, provides something to standard output, and that's it. And this is already given to you. What you need to implement? You need to implement class called tttnet.java, which works as a networked frontend for this TTT-CLI. And it should work in following way. So if we have this TTT-CLI, an interface for it is, it reads from standard input, and it writes the standard output. But you have to implement TTT-net in two different modes. In server mode, it works the following way, that if it can run in server mode, and I will show in details how you check that it can run in server mode. It works as a networked front-end for this TTT CLI, and instead of reading and writing from standard input to standard output, it should create network socket. And it reads from this socket and provides this to standard input. And it reads from the standard output of TTT CLI and writes back to the socket. Reads from socket and provides it to standard input and writes to socket, which was provided here in std out. That is one mode. And another mode is you can run it again. That it works as a front end for networked application. So it reads from std in and it writes to std out. But what is happening here in difference with TTT CLI, actually this application could be run in remote. And what is read from standard input is written into network socket. And what is read from network socket is write into standard output again. So idea here is that you can start developing real networked game or application where some of clients may be connected to the server from one computer, another from another, and then you can do this game actually in two different persons on two different computers. So it is not required in this particular step. That would be some extra exercise if you like. So here both clients or real humans still need to sit on the same computer, but if you could implement in future like two network sockets, another network socket here connected to this server, then it could read from one socket, execute this game, provide to another client, read from this socket, provide to that, and provide it to another client connected to the server. So that's what you need to implement. First is the server mode and second client mode. Any questions or comments so far? Is business requirement understood? I take that as a no comment, which means either everything is understood or nothing is understood. So later I will show you how you can debug it, because as soon as you start developing networked applications, you need to know how to check how these are working. And one of tools, particularly for Linux operating system or Linux based operating system, is a tool called SS from server sockets. Old school tool which works in any Unix-like system is netstat from Network Statistics. And netstat also works for Microsoft Windows. But when different kind of virtual machines and containers were introduced, etc., this tool was considered obsolete because of how it assumes that MAC addresses are related to IP addresses. So particularly for Linux, this tool, for example, if you try to run some in modern Linux-based distributions, usually it's not even included by default when you install every tool, which are considered basic set of tools. So you can install them additionally if this is only tool you know how to use. But particularly for Linux, this more modern, better suited tool for modern world is called SS from Server Sockets. But switches, what you can use for this netstat tool and server socket are very similar. So if you know how to use netstat, probably you will know how to use SS very easily. And SS and TLP means show all sockets, use numbers for IP addresses, you show only TCP connections, show only listening connections, not all connections like client connections, and also show process ID. And here I can see how many processes are listening as a servers on my virtual computer. On this port, on localhost interface, this port, localhost, all these are localhost interfaces. Only this particular port listen on both Internet Protocol version 4 and Internet Protocol version 6, and this reminds me that leading zeros are padded with 2 colons, not single colon. And so this is one of diagnostic tools we may need to use later. So now about implementation. As usual, design for this class is already given to us. We just need to write some code inside this design to actually implement these things. And if we analyze in more details this TTT CLI, we see that it's already created in quite general way, that instead of hard-coded standard input and standard output, constructor for this TTT CLI actually takes input stream and output stream as a parameters to it. And particularly in main method, when you start it as a Java application, for this input stream and output stream, system.in and system.out objects are given as a references to these streams. But when we run it as a backend or business logic for our TTT-net, this server process, then of course instead of standard input and standard output, we may give input stream and output stream from our server socket. And that means that here design was actually future proof. We can extend it quite easily to work through the network. So the first thing we need to do is we need to create a listening process which will be listening on specified port, on specified port. So if you specify only port, then it will listen on all possible addresses. And for this virtual computer, this means localhost interface with following address starting 127, and these are all aliases. They are different addresses, but they still will rely to the same virtual localhost interface. and this address, which is wired network interface for this virtual machine. So what do? We need to create server socket object, which is already declared for us, but we need to initialize it. And we say something like server is server socket, but we will use constructor which takes one integer as a parameter, port number here. And this port, as you see, it is one of another public constants for our test project declared here in alltests.java test suite. So in this case, port number will be 7701. And then we need to try to run server accept method for it. And if it will succeed, it will return reference to the socket object, which is container of input and output streams through the network. And with that part, we can test it out, how it runs so far. For example, if I run it as a, and you see that here, what I'm implementing here is everything is inside main method, so it is runnable as a Java application. So if I run it, and I check what do I have running now, I see here that there is process with this process ID running and listening on port 7701 on all possible IP addresses. So that means Internet Protocol version 4, Internet Protocol version 6, and all these possible address, localhost address, blah blah blah. And I will not test it how it works yet, because except that this process is listening on this port, nothing else is implemented yet. So next thing, to get something working, in server mode it is quite easy. We just need to connect these pipes properly, that for this created socket, when we execute this .accept method, it will return our this socket object where we can get input-output streams and we can attach readers writers to it. We need just to reconnect this stream to that stream and that stream to that stream. And so that is what we do next. And here again we have quite a lot of hints that we say that input, which is where it is here, it's declared here, input stream, is where you can read something. An input stream is this socket object, get input stream method, and output is similarly socket object get output stream object. And again here precise types of Java helps us a lot, because if it's input stream and we mismatch something and we try to say get output stream, we immediately get compilation error. So again here precision of data types helps us a lot, because we cannot connect these pipes, let's call them, in incorrect order. And so we have established this piping, we know how reference to input stream and output stream, and now we need just to create this backend which will actually do this real work of this business logic. So business logic is happening here, and what we do is we do following thing, that we have TTT CLI as a part inside it, not very well encapsulated, it's not private, it's protected, not protected, it's a default, but we can now initialize them, and we say it is new with this, what was order for them, there is constructor for it, probably input output and int size. And for size, initial size in this case for networked mode is 0. Now we have, of course, it is constructor. Don't laugh at me, sometimes I forget to write this, sometimes I forget to write that, because for me this is too verbose. Usually I would think only this is enough, or only that would be enough, but yeah, that's how Java syntax works. And now we have created, but if you look how it actually works, is that this looping mechanism of reading, writing for each particular step of game is actually implemented in play method of this standard input-output oriented game. And to start doing this, we need, of course, to call play method to start handling these moves. And when we have went so far, we can even start testing something, because here it's not tested, but as you see, for server-side perspective, to run this TTT-net as a server should be done. So double check that there is no any process running. You can double check that there is nothing listening on port 7701, and then we can run it. Nothing visible here, but if we check about listening process, we see that something is listening on this process, and now we need to communicate it with this server. Old school application would be telnet, and we could say something like localhost port 7701. But I don't know about how I configured this Xubuntu virtual machine, but I also may not be surprised if it will say that telnet application is not installed by default. Telnet is good for debugging purposes, but before Secure Shell or SSH protocol, Telnet was used to interact with remote servers, because what Telnet does, it reads from standard input and sends this data to remote server. These commands are executed on remote server. These are provided into standard output, which send back through this Telnet connection and then print out on your screen. But there is no any encryption between client and server, and it could be secure enough if you do this in local area network in your office. Totally wrong to do this in the internet, because then everybody can read the data transmission as open book. And instead of that, Secure Shell is used to do the same, but with data encryption between client and server. And because of that, Telnet may not be installed because it's not widely used anymore on different Linux distributions. It's definitely not installed by default on modern Windows workstations. You need to search how to install it for modern Windows separately. But for Linux-based distributions, leading tool for debugging purposes in networking is a tool called NC or Netcat. So you know that cat is like print out content of this particular file, and Netcat, which is shortened for just an NC, is doing something similar through the network connection or this network socket. And we can use, let's double check that this is still working. So Netcat is similar to concatenate or send content of files, but not for the local files, but for remote services. And you write something like Netcat. You can write localhost here or some specific address, port number 7701. And we see that it even works. Only difference is that requirement here is that by default size of board is 0, so only thing we can do is to check network connection. And if Telnet is actually working, and for debugging purpose it's easier to run it through the terminal. Let's order this in such way. Let's say board size is 1. And we enter 0 and game has ended. If we say that border size is 2, then we have more complicated situation. We can even play it for a little bit of time. If you use Telnet, then Telnet prints out additional information. So this is not coming from a remote server. This is coming from Telnet application itself. It says to which address it tries to connect to. It says what is escape character. For example, how you can say to disconnect this connection, which means press Ctrl and or in quick sequence these characters, or which is the same as Ctrl C. And then, for example, when game is ended, for example, Telnet works a little bit differently. When it sees that the server sent this final packet from remote site, it exits automatically. But if you do it with Netcat, you don't see any of this information because Netcat do not provide additional information here. And for Netcat, you still need to press enter to exit out of it when server has ended this connection. So this may be important, like that you need to add additional line break here for Netcat when you are debugging and to see how this actually works. For example, reading this data. So this enter here, what I'm pressing here, is needed for netcat, but it doesn't mean that the server still tries to read something from this input. And as you can see, if our backend implementation is quite general, like it already can deal with input-output streams, then converting it from standalone application which handles and reads writes from standard input to standard output, and then to do it through the network socket is quite easy. Of course, it's not easy if today is first day when you learned more details about how networking works, but if networking itself is not too much new things for you, then this part shouldn't be very crazy to you. So now about second part. When we run this TTT-net in client mode, how do we run it? We run this same class again, and it tries to create listening process on this given port 7701 by default. And if it fails, assumption is that there is already proper process listening on this port to provide this networked game, and then it needs to be run in client mode by reading the standard input, writing to the socket, reading from network socket and writing into standard output. So these things. And it is just an assumption. If there is some other process listening on this port or something else breaks for some unknown reason, then of course this assumption may be wrong and it may still not work. But if environment is proper and there are either proper servers listening on this port or this port is free to use, then it should work. And so here is one of these few cases when we catch this exception that you cannot run. I will show you. So it will not be proper implementation for client, but to demonstrate how it looks like. If I try to run it again, we saw little bit misleading error or exception in Java. Address already in use. What is actually already in use is a particular address together with port number, but for some reason they decided to not mention port number here but only address. So this means you cannot run another process which listens on the same address and the same port number. Only one process may handle it, because only one can be a receiver of these particular packets with this IP address and this port number. So there may be other exceptions, but we can, if you want to be double sure, you can check what is a message field. And for example, if the message field is address already in use, been filed for, it is bin exception, then you continue. And if something else, you print it out as some general error. But we, again, are not so much interested about robustness of this application and error handling. We are more interested about networking here. So we will not do any funny error handling here. We will just assume that if this first try fails, then server is running and it's running properly, and then we will try to run it as a client. So for client, we need to initialize socket object, and in this case we create new instance of socket object, and constructor now is different. We need to say two things. What is host to which we want to connect to, and we use variable for that, host and port. I think in this order. So we have an established client side of this socket object from the server socket. That shouldn't be too hard. Now we need to do piping, and piping is quite complicated. Because here for this TTT CLI, its design was already quite, how to say, future-proof and handy for us to create. We just needed to pass different referents for input and output stream for this business logic part. But now we need to do all the piping by ourselves. And what do we need? We need to create a reader which reads from STD standard input. We need to create writer which writes to the socket. And then we need to create reader which reads from socket, and need to create writer which writes to the standard output. And then we need to do it in infinite loop for until game ends in following order: read from server socket and write to standard input. Okay. Read from server socket, write to standard output, read from standard input, and write what you read from standard input into read from server socket and write to standard output, read from standard output and write to the socket. An order very important, because when we start this game, first we need to see this board on screen. If you will start with reading from input, it will wait forever, because non-blocking input-output operations, or the standard I/O operations, are blocking. If you try to read and there is nothing to read, it will stay there for infinite time. But if you try to read something from server socket and there is something to read, then of course you will be able to read and continue this loop without waiting on some unreadable thing forever. And here is this correction part. What we will try to read from server socket is called SRV in. And again, here it helps a lot that Java is strongly typed language. We can't go completely wrong here with these hints. We need to create new buffered reader. And then, because we need buffering, I told you why we need buffering, then new input stream reader. And then, if that would be file object, we would also need to create new file handler. But if it's input stream from socket, we do get reference to it using method. So that's to read with buffered way from the socket of from the server side. Then write to standard output, new print writer, and I told you where print writer is better than buffered writer. So complete symmetry would be also new buffered writer, but for new buffered writer problem is that it's too generic or too abstract or too general. Instead of print line, we have to use just write method, and then we need to care about line breaks by ourselves, and that is hard. So that's why here you don't see full symmetry here, because print writer is more handy writer object than just buffered writer. We could use buffered writer here for full symmetry, but we will not use it because this print writer is more easy to use. And then we need to attach it to system output, and you get reference just to system system.out. Then standard input, input stream reader, but system.in as a reference where we actually try to read from, and SRY out is new print writer, and then socket get output stream. So piping is now done, and it compiles, and I think it will also work, because if it compiles, probability is very high that it will work, because Java is strongly typed language. If these types would not be very strongly typed, we could mismatch these inputs with outputs very quickly, because everything could be very similar. So that's about piping. Now we actually need to implement these steps of read, write, read, write, read, write, in general into infinite loop, but then of course we'll need to think about the halting conditions to stop this infinite loop. But in general, we read message from the server and print it out to standard output, then read something from standard input and send back to server. So initial thing would be something like this, or first iteration. Let's say we will introduce some local variable here for debugging purposes first. From server in read line, and then we can say server out print line what we read here, and then we say, and I'm reusing the same variable. Some say that this is not a good thing to do, because then the debugging becomes a little bit harder. So we read from std in read line, and then we send it to, oh no, what we read from server, sorry, we print to std out, and what we read from std in, we print to print line, how it's called, server out, print line, So that would be something like a proof of concept just to check that we have not messed up inputs with outputs and sequence how it should work. Let's try it out. So now it should also work in client mode. And unfortunately nothing happens for me here. Let's double check read lines from SLA in. Here, this is that to do. Print to std out. Read from std in. Print to server out. Okay, we will try to do in more simple case. Let's say with 0 fields. And still nothing happens. Okay, maybe it's not debuggable. So what is problem here? Problem is following, that if I run CLI, actually I need more than one line to print. I know what is problem. As usual, these are all buffered writers, and at the end of iteration what we need to do is std out flush and server out flush. That's, I think, first problem why we can't debug it properly, because it should work. So let's try to run it again. And you see, something even started working. But see here, problem is that when I run it in normal command line mode, I actually need to print out several things depending on size of this board. So I actually need to do this inside loop. So what I'm doing here for read line, I need to do something like while, and currently I will do true, which is completely wrong. And std out should be flushed. Let's say for each particular line. After that we can put this flush after this loop here. And now it should work. And this is quite funny about local variables, that compiler requires me, this may be something else, unreachable code because it's true. Okay, well, so this is still wrong, but at least I do not have compiler code. So what I wanted to say here, that compiler says through the Eclipse that this local variable should be initialized, and when I say it now, compiler is happy. It doesn't mean that I will not have different kind of runtime errors, because you can't do much of this TMP. And remember, if I would start with TMP equals literal value of string, I would get null pointer exception here, because you can't do compare and call any method for null reference. I'm not running proper one. TTT-net, let's say, see, null pointer exception. So, but if I start comparing it in opposite direction, literal declared string here tmp, so it will be better. And it doesn't print anything. So what can we do? We need to implement it correctly. And for any text, many of internet protocols are text-oriented. Why they are text-oriented? Because text-oriented protocols are much easier to debug using basic tools like Telnet and Netcat. And for text-oriented protocols, there are different kind of tags or identifiers how to know, for example, when stream has ended. Because if you read from local file, operating system knows, similarly to arrays in Java, for each file there is very important identifier how long file is. And inside this file you just can have null bytes, but operating system knows how many null bytes it needs to be reading. But for network streams, you never know how long this stream is. There may be some of network protocols where you need to first say length of my data will be, let's say, 60 bytes. For example, when you do post request in web, you actually need to say how long buffer needs to be created to contain all this data. But it's still just suggestion. It doesn't mean it is very precise. It says how much of data should be buffered, not what actual length is. But for such many protocols, you have different kind of identifiers to know where stream ends. For web protocol, it means empty line like this. But in this protocol, we can understand that we can finish reading when we reach this enter place, because when we have reached enter place, this means we are done reading from server side. And we do something like this. And it will be without line break, because we read line, and this means everything till to automatic line break. And it is while not and I think this should be do while, not while, but we can test it out. So let's run network application here. It even works. And now here it stopped, so we can leave it for now. Let's try to debug with bigger field. Okay, so we can leave it for now as far as it works somehow nicely. So that is one loop inside this. And then, of course, we need another loop for many steps. So here, again, we need some while. True, of course, is completely wrong. And now, while this is working, we can actually flush buffer only here, print, because here we would flush buffer for each particular line, which would be slower. But now we will be flushing only when all needed lines are printed out into buffer. Of course. Okay, let's do this without this loop yet, just to check that with this reworked flushing it still works properly. Yeah. So that part would be more or less done. So now this is and this is handle many moves. Something like this, and this will never end, but we can check how does it work, at least until it should be ended. let's make board smaller, only one. And see, here we have infinite loop. Null is readed, but to stop this infinite loop, we see that here this halting condition for that loop, good is condition is game ended. So we can do something like not equals b, and then of course this should be outside of that while loop as well. While not game ended, something like this. But it still prints out nulls. And why it prints out nulls is because it gets this game ended, but I think it still goes here into this loop. I don't know absolutely correctly. So what can we do here? We can add here from SRV, and here we can from standard output we print only here, so that's where it goes into break. So what can we do? We can do another check mark here, like if game ended, like just a workaround because of this loop. We need to check out where this infinite loop happens. And maybe here we need to add. So our code becomes quite ugly, but we will optimize it when we will get it working. So while it's not either enter place and it's not game ended, something like this maybe will work. And now it still continues to work. So we can do something instead of this. We can do another ugly workaround. If in this loop, and then we will check which loop is actually needed where. Of course, if you are a real programmer, you could do it in a different way. You can think and understand code what you are writing and execute it in your head. But for me, as an occasional programmer, testing is easier. And now it exited too quickly. Okay, we can. And here we will do, because first we need to do something like this maybe. game ended was not printed out. And I think this should be somewhere in this place. So now it goes correctly till I enter game, but game ended is not working correctly. And here is one of things when you can decide to do two different variables, because now I am mixing what I have read either from standard input or from server. And that means I need to do two different checks. Enter place is marker to finish reading from server side, and game ended also comes from server side. And now I have quite an ugly code here. So let's check it back how it worked with this particular implementation. So this needs to be improved because it goes into infinite loop after game ended. This part should be it reads enter place, and it needs to exit after game. It needs still to print it and then exit. Something like this maybe is proper order of events. Again, now it exited too quickly. I'm just testing here. If you have better options how to deal with this, you can say me, but this is my approach. I think that in this case I need proper debugging to understand where this infinite loop and how exactly it happens. So it printed out game ended. But then, so that means, so this should be somewhere here to break out from this loop. But now game ended, it's not printed out. Okay, let's try to debug it. So we can run server in one terminal, and here we will run it as a client. I know what is problem. Again, problem is with buffers, because if it exits, it doesn't flush buffer. So it doesn't look nice, but now it should work. So it exits, but game ended is still not printed out. But it should be printed out because we read it, it's not enter place. It needs to be here. Maybe this will work as I expect it to work. Oh, now it even somehow works. Let's make it more complicated. Okay, and now we can try to do also run JUnit tests. And let's run it. Okay, so now it works. What we can do, we can save it. And now we can think about improving. First thing is, this is very bad thing to do, because here we are not closing any connections to the server. So here at the end of this loop, what should actually be happening is server out, close, add and end, std out. But if I do something like system exit here from this loop, of course these things will never be executed. Of course I can do something like this. But it's quite ugly, because now I have duplicated code. Problem here is following, that I have to exit through two loops immediately. Here is one loop, and here is another loop. And with break, with normal break, I can exit with only one level of loop, but I have also to exit another level of break loop. And this works nicely, because now it sends to the server to close sockets. Oh, it doesn't work nicely. Probably because I had running server here. Yeah. But this and this is not very good. Game ended here. Two places is not very good. So we may think a little bit about optimization, at least for a few minutes, how to do this. And then of course this variable, because we need to remember it, because we check here for these values. So this variable currently is needed, and then of course here we do it suboptimally, because in general we could need to flush standard output only after this loop, or before we close this stream. So here game still continues. Here we need to flush it, because now we are going to end this client mode execution. And don't be surprised if sometimes this test passes, sometimes not, because a network is involved. If there are some timeouts, etc., they may fail. Then you can do manual test, check if everything is okay. Then it's okay. So now from business logic, everything is nice. We are flushing buffers only when it's needed, either after loop of printing out this board status, or when one particular move is finished, and to send it back to the server. But here we have quite a lot of duplicated code. Here for checks, etc. One thing what we can do is to break out of it through this loop. So instead of system exit here, you do something like this. But then problem will be how exactly you exit also from this outer loop when you deal with moves. And one thing of course is to check for game ended again and again and again. For example, like here we have game ended and here we have game ended. But my recommendation is something like is use some much simpler thing. Instead of rechecking for game ended again and again and again, we exit from its inner loop in following way, but then we say that stop should be true. And then I think that instead of that, if I can follow my logic correctly, and of course in more serious cases I cannot follow my logic correctly, is while continue, or whatever it was called, stop false, no, continue is keyword. Okay, it will be stop, and then it will be while not stop. And let's first try to run it manually. And it looks like it is maybe working. So nothing is listening here. Yeah. So then I introduced some more complexity here with one variable, which is bad of course, but I got rid of duplicated code here, and I got rid of duplicated code, for example checking for game ended here, and therefore probably what I did here. So I can delete that one, and I can delete that one. Probably this implementation is a little bit better, because first I flush buffers as infrequently as possible, because if you start buffered writing and you still flush buffers every time, you just added complexity with buffered writing, but you still send all this information by small bits every time you flush it. So doing buffered writing and flushing regularly doesn't have any sense. You just make your program more complicated but not faster. So we are doing flushing as infrequently as possible, and also we are nicely closing connection to the opened file. We are nicely closing connection to the server, and of course you can close it for close, but this is not so important. And what is also, let's turn that in close. This is not so important because readers do not reserve any data for exclusive access. But if you like symmetry, then of course you should close gracefully readers and close gracefully writers, but closing writers is much more important, because otherwise, depending on how stupid your operating system is, how busy your remote server is, you can just make it unusable after few attempts. And there's not too much of code here as well. So this particular is not insane implementation. You may still think about, and now we can go back to TMP variable. How many times do we compare it? So I think we can declare it inside this loop here, because as local variables are as better. But this of course should be outside of loop, because that's how we say that continues this loop here, but then break it here. So that's about this particular exercise. Any questions or comments on that? And of course, then we can explicitly close socket. But particularly for SRV in, if you check how socket is closed, somewhere here you will see that internally it also closes all its internal streams. So you can SRV, and one thing you can optimize just amount of code is following, that what you have here is very conservative, very bureaucratic approach. First we close data streams separately, and then we close entire socket as a container for these two data streams. But behavior will be absolutely the same. Yeah, in virtual machine it works a little bit unstable. This is absolutely the same as just closing socket. So this is also a valid solution. And why you need to decide, for example, to close streams before actual socket, which is container of these streams, is, for example, you need advanced logging about particular streams and stream handling, etc. So I will leave it here. As a little bit improved implementation. Yeah, so I think I do not have more comments about this. Do you have any questions or comments?